Now we're in the next section of the series. I'm going to go over a few external state management libraries and give you my opinion on them. My goal with these videos is to give you a sense of what state management libraries you may want to use and a brief introduction to them. To get started, we're going to take a look at Recoil. It's probably the newest of the bunch, and it's actually open source through some people at Facebook. Let's get started by making an app container once again. In this app container, we're going to return Recoil root, which you can think of similar to the provider that we made with our context. And since it doesn't want to auto import, I will type it up here. We'll import Recoil root, and that's from Recoil, which is already installed in the project you have in front of you. And then let's return the app there. Let's go ahead and go into our root index.js and make sure we import app container. And now we come back and there's really nothing new because we're not rendering anything yet. With that done, let's simulate a little application. So let's put a div inside of here. Let's have a nav bar. Let's do blog post. And let's also have footer. Before we make these components, let's actually set up our Recoil state. So let's make a new file and let's call it use page state. So let's get started by importing Atom and use Recoil state from Recoil. So in Recoil, an Atom is just a piece of state, and use Recoil state can be thought of just like use state, but instead you're using an Atom, and you'll see here. Let's get started by making our first Atom. So let's call this page state. And we'll say page state equals an Atom, and the way this Atom API works is we give it a unique key. We'll call it page state. These just have to be unique. So if you have a bunch of different slices of state or a bunch of atoms in your application, the keys just need to be unique. And then you can set a default value. For now, we'll just set it to home. And then you use this very similar to use state. So what I like to do is export something called use page state. Since we name this page state, I always export use whatever the name of my atom is. And then I will say use recoil value. Use recoil state, page state. So far, you might not understand what this gives us over use state, so I'm going to show you shortly. With that in place, let's actually use it, and then you'll kind of see the power of it over normal use state / React context. So let's jump back into our app.js. Now let's make the footer component. And inside the footer component, let's put let page equal use page state. And then we'll return a div that just says the current page is page. All right, now we also need to define navbar and blog post. So let's do that now too. Let's act like blog post doesn't need to know about the current page. In a realistic application, it probably would, but for now we will just say div the current blog post. And then we'll also add a console statement here just saying re-rendering blog post. This is going to give us a comparison to how use context would differ from Recoil. Lastly, let's make our navbar component. Before we do that, let's make a pages array, and let's just give it a couple pages. Home, about, featured, and then let's make the navbar. All right, so in this navbar, we're going to pull out page and set page from use page state. And then we're going to return a UL, so an unordered list, and we're going to loop over all the pages. I meant to make this plural. Pages.map, and we'll call this name here just to help us with some logic we got to add. You'll see in a second. So let's add an li, say the key is the name. We're just assuming every page is going to be unique. And then inside of the li, we will also render the name. And then we will need to add an onClick here. And inside this onClick, we just want to set the page to whatever page they clicked. Lastly, we want to show what the selected page is. So we're just going to add a style attribute here. We're going to say the color. And then if the page equals the name that we're on, then we want to make it red otherwise black. So I'll just summarize one more time. So the current page is coming from a recoil state, and we're just checking here as we loop over if the current one we're on, so if the name equals the page, then we're going to make it red. And so you'll see over here, it's rendering now, and when I click, it's changing. So you'll also notice another thing here. So it says re-rendering blog post, and when I click and change state, it's not re-rendering the blog post, which is what we want. If we had built this out using React context and put a context provider around here, our blog post would get re-rendered every time, because of the way context works by default, whatever is under it will get re-rendered anytime that context changes. So the power of Recoil is that you can define these little atoms wherever you want. Different parts of your application can listen to this page state, and only those parts get re-rendered. So it's very powerful if you had a list of components like this on the screen, and maybe some of these in here didn't need some of the other state. Also, if we wanted to do a use state with this, we would have to put it in the app right here, and we would have to pass down the value, and we'd also have to pass down set page to every component. So when you use Recoil, you don't have to worry about passing props down, and you get re-rendering handled more efficiently than context would out of the box. There's a little bit more to Recoil. You could check out the docs, but this is the basic idea, and I think it's a pretty great way to go about managing your state. In this lesson, we're going to be going over xState. To get started, let's go into our root index.js and make sure we just import app from our current folder. We're going to get started by making a new file and call it use-to-dos. xState is all about a concept called state machines. In my understanding, it's a way to encapsulate everything to do with our state in one spot. Let's get started by importing useMachine from xState/react. And then let's import machine and assign from xState. xState supports a variety of different libraries, as you can tell by the way their packages are set up. The main core functionality is in the xState package, and the React-specific bindings, in this case the hook we need, is from xState/react. We'll get started by making a very basic state machine called to-dos machine that'll represent a basic to-do app. So the way we do this is we call the machine function, and inside of this object is going to be everything related to this state. We give it a unique ID first, and I'll call it to-dos. And then we start off with the context. So this kind of represents our initial values. I'm going to put to-do as an empty string, and then I'm going to have to-dos, which is going to be an array, and I'm going to put first item in there. Next, we can define a list of actions. And the way that works is we add the on key. I'll name one to-do.typing. This will represent when someone is typing in a field but hasn't yet hit enter when they want to add a to-do. So inside of here, I will say there's an action we want to run, and this can actually be an array, but for right now we just want to run one action. So we can say assign to-do, and each of these fields take a function. CTX is the current context. Right now it would just be this value. And the second argument is what's going to be passed in by the user when this action is called. We're going to give it a target, which is a DOM element. And we want to take that DOM element's value whenever they call this action. Now we'll add one more action. We'll call it to-do.add. Sorry, let's make that plural because we're adding a new to-do to the list. And this one will also have an action. And we're only going to use one, so again, we won't put an array here. And this time, whenever someone adds a to-do, we want to make to-do back to an empty string, and we want to push to the to-dos. So we'll take CTX and the target, and we will spread the current to-dos, and then target.value. And now down at the bottom, let's add an export use to-dos, and that will be use machine to-dos machine. Now that we've got this mostly finished, let's go into our app and set it up. We'll start out by saying let state and send, which is very similar to use state, but it's obviously a little bit different naming. And then down below, we're going to return this div, and inside of here we want to put an input, and below that we want an unordered list, which is going to render all the to-dos. So we'll say state.context.todos.map. And for every to-do, we want to render an li with the key of the to-do. And then inside of it, the value is also the to-do. And then we just need to hook up our input field. So we'll say that it's a type of text. The value is going to be state.context.todo. And then on key up, we're just going to define what happens when they hit enter. We just want to say if the e.keycode, as we've done many times before in this course, is 13, then we want to send todos.add, and the object we want to send, in this case, e.target. Otherwise, we don't want to do anything. We'll just put null. And let me close that correctly and hit save. Lastly, we just got to set up the on change. So we do e and then send todo.typing e.target. So one thing we forgot to do here is we need to go back into use to-dos. And below context, we need to add an initial state. And we're going to add initializing. And now once we have that, we need to define this state. So we're going to say initializing once more. And we want to define an action. So whenever this state is happening, actions is plural, we want to set to-dos from context. So ctx.todos. And we can't forget the comma down below. All right, now that we have that out of the way, let's go back to our app and let's type something. We type test, hit enter, and it works. Now what if I just hit enter like that? Well, we keep adding a bunch of blank keys. We don't actually want that to happen. So with xState, you can do something kind of nifty. We can come down here to our todos.add, and we can add this condition. We can get access to the current context, which we don't need in this case, and the target that's being passed in. And we can say if target.value, and we can trim it just to be extra sure it's not just blank spaces, .length. So if this is like returning false, it's not going to actually run the action. So now if I type hello, it works just like we would expect, but if I just hit the enter key, nothing happens now. So this is kind of the point of xState. We can control everything to do with our state in this one big object. It also gives you this really cool way to visualize it. xState has these graphs, but it can also be kind of daunting to a new user. Also, I've only used it a few times, so if I made a minor mistake explaining something, I apologize, but you can learn so much more about xState from their official docs. I hope this gives you a good brief introduction to it though. In this lesson, we're going to be going over Redux. Redux has a very similar API to useReducer, and I think you'll see that when we get started. Let's get started by making a store.js file, and then let's import create store and combine reducers from Redux. Before we use those, let's actually make our reducer, which is something we've done before. So let's make a to-dos reducer. And let's say the state is going to be defaulted to to-dos as an array and to-do. So kind of mimicking our last episode that we went over with xState. And then the second argument is always going to be the action when you have a reducer. So then we're going to do the typical flow. We're going to have a switch statement and we're going to switch on the action.type. And then let's add a case for to-do.typing. Except in Redux, the convention is to add underscores, so I will do that here. And let's fix the colon on here. And then let's just say return the current state, and then whatever to-do was typed in, so action.todo. Next, let's add another case, add to-do. And then when we add a to-do, start off the same way, spread the current state. But we're going to set to-do to nothing. And to-dos is going to be added just like in the last lesson. State.todos, action.todo. And then let's add the default case so this annoying warning goes away. Default to returning the state. So our reducer is set up, so let's actually build our Redux store. So what I'll do is I'll do export const store, and that'll be equal to create store. And then in create store, we're going to call combine reducers. We do this just in case we have more reducers in the future, which in a realistic app, you'd have more than just this to-dos reducer. This would be for every piece of state you have. So you'd create one reducer for anything else you need in your application. Just to simulate that, we're going to use combine reducers with just one reducer. With that set up, let's go into our app.js. We need to get started by exporting an app container because Redux needs to wrap our entire app. So we'll start off with app container, and then we will return provider. And this will be imported from React Redux because it's specific to React. As you can imagine, just like xState, you can use Redux in many different scenarios and many different applications. So they have their packages split up with the React specific bindings as well. So now inside this provider, let's return our app. And we also need to give this provider our store. So let's say store equals the store that we made, and we want to import that. Now that that's done, let's save it. And then let's make sure in our root index.js, we go back to importing app container. We can just do that, and now the app container is getting rendered at the top level. And you'll see nothing different because our app doesn't do anything yet. So now inside of our app, let's say let dispatch equal use dispatch. And let's also grab the to-do state. So let's say let to-do's state, which I guess to-do state singular makes sense. Sometimes it's so hard to name variables, as I'm sure you know. So let's do use selector, which is going to let us select just a small portion of our Redux state. And it's just a very simple callback with our top level Redux state. And so in this instance, we want to say state.todos. And we need to make sure we import these at the top as well. For some reason, VS Code doesn't want to auto import for me today. Now let's go down here in this div and let's recreate what we had with our xState lesson. So we'll need an input field. We'll need to give it a type of text. We need to define an on change. In that on change, we will say dispatch, and we want to dispatch a type of to-do typing. And then the to-do is e.target.value. And now I need to close this so that it doesn't error. And we can add the next one now, the on key up. Let's say if e.keycode is 13, then we want to dispatch another action, type of add to do, and the to do is e.target.value just like before. And I forgot to add the second part of the ternary. All right, so we have that. Now we just need to actually render an unordered list. So let's put a UL again. Let's say to-do state. I really keep messing that up, don't I? And to-do state dot to-dos, map over those, and for every to-do, we're just going to render an li, the key of to-do, and a value of the to-do. Cool, so let's type something now, and we see it gets added, but it's not actually getting cleared, and that's because I didn't set the value here. So to-do's state dot to-do. And now when I type and hit enter, it's going to clear. So it's very similar to xState, but you might find this a little bit better API for yourself. The difference between this and use reducer is really just that your store is created at the top level, and this provider provides it to anything in your app. So if you change a piece of Redux state, it's available anywhere. Just like with Recoil and all of these other solutions. It can be a very nice second step if you're already used to the normal built-in use reducer React methods, because there's not much different. You just need to create a store, have a provider at the top, and you can use reducers just like you were before. Alright, in this last lesson on state management libraries, we're going to go over Apollo Client. Apollo Client might seem very complicated or very different than what you're used to if you've never worked with GraphQL before. To get started, let's make a new file and let's call it client.js. We're going to import Apollo Client and in-memory cache from Apollo Client. Next up, we're going to export a const called client, and that's going to be equal to a new Apollo Client. And Apollo Client just takes a couple options that we need to pass in. We need to give it a URI, and we also need to give it some type of caching. What's really cool about this is you can have like native storage caching if you're on like React Native. You can have a local storage backup, so if you refresh the page, your state is still there, and it's all just kind of built in by these cache adapters. So in our case, we need to just put in-memory cache here. And then for the URI, you can copy this from the lesson folder. It'll be in the lesson 19 folder for this file because it's a little bit hard to type out, so I'm just copying and pasting it. This is a sandbox that Apollo client themselves put up, and you'll want to save this, and then you'll also want to take that URL and you'll want to open it in a new tab so that it's actually running. So I'm going to load it up here again. It's going to initialize and start this server. So it should only take a few seconds, and you'll see here that it's done. With that being done, you can just leave that page open. And let's make a new file over here. Let's call it use exchange rates. So inside of this, we're going to make a GraphQL request to a server. None of our other examples have even gone to a server. It's all just been local state management. Apollo will actually do a network request for you and manage all of that state. So there's really not much you have to do. With Redux, you need to manage actions. With GraphQL and Apollo, you could just run a query and it will tell you if it's done, if it's changed. And if you want to mutate something in that query, you can do that in GraphQL and the state changes are all handled for you. It's kind of hard to really get into in this short video, so I'm just going to show a quick little example of running a query using Apollo client. So let's import use query and also the GraphQL template tag helper from Apollo client. And then let's make a variable called exchange rates query. And that's going to be equal to the GraphQL template tag function. And inside of here, we actually write our query. So we're going to name this query get exchange rates. And there's this GraphQL query available to us on this example sandbox server that gives us exchange rates. So we want the exchange rates and we want to give it a currency of US dollars. And then inside of this query, we just want to grab the currency field and the rate. And now down below, we can just say export const use exchange rates. You may notice that I've tried to follow this use pattern based on whatever the thing is that I'm getting, no matter what library we're really using. So then I just say use query. If I can type the arrow correctly, say use query exchange rates query. All right, so now we're all set up to actually do this GraphQL query. So let's jump back into our app and get that set up. Down below, we need to export again an app container. And then that app container is going to render an Apollo provider. And then we want to give it the client that we just made. And return our app inside of it, just like any other provider that we've done. And I forgot the return keyword. With that in place, up here we can actually use this query. So we can grab data and loading from use exchange rates. So Apollo's use query hook gives us a few other things, but the most basic is it gives us the data and it also gives us this loading boolean. So it's another thing we just don't have to handle ourselves. So what I like to do is we can say if it's loading, we can return loading to the screen. If there's no data, so if loading is false and there's no data, we can just return no results. Lastly, it'll fall back to our return statement here. Inside of here, we're just going to return a straight up array. So we can say data.rates, and we know that data.rates exists because in here, the way the data object works, whatever is inside this query is the name of that key. So it's called rates here. Over here, it's going to be data.rates. And we can say data.rates.map, and whatever that rate is, we want to render a div. We'll just give it a key with the rate.currency. And then inside of it, we're going to render rate.currency and whatever the rate is currently. Let's save that, and you'll see it says loading, and then it pops in all of these exchange rates. So that's a really quick look at Apollo client. It's definitely my favorite way to manage state in React, mainly because local state management isn't something I have to think about so much. Mostly everything just comes from a GraphQL server and it's all handled for me. If you're using TypeScript, you can also automatically generate TypeScript types from these queries. So it would even tell you like, hey, rates isn't always an array if maybe it was sometimes not defined, or it'll tell you currency is a string, and you never have to write those types for yourself either. I know this could be more advanced than you were hoping to get into, but I wanted to make sure I showed you guys a few different state libraries to get you excited about. I'd recommend just picking one of them that seems interesting to you and just researching it and trying to run with it. Having more React experience with different state libraries is only going to help you in the long run. So I hope you like this section of the course.